Welcome to week 3. We've made it all the way to week 3. This week we're talking about research methods. Now, compared to last week, this is going to be a little more difficult. There's a ton of vocabulary, there's a ton of applications and stuff, and we'll be working on this in class as well by doing hands-on activities to make a little bit more sense and go through all of the major concepts at a deeper level. So let's get started. Research. Okay, so how does psychologists develop new knowledge? How does it all come out? All of psychology is based on research, okay? Just like we talked about last week, it's the science of taking concepts, applying them, and getting the most out of it by using the scientific method, all of those observations. Psychologists, like researchers and all other sciences, use the scientific method to test their ideas empirically, okay? Solid research. Okay, so what is empirical investigation? An approach of research that relies on sensory experience and observations. Okay, so we are not just making guesses, we are looking for science, the numbers, and viewing. Okay, so the scientific method is a 5-step process for empirical investigation. If you've ever been in a science class and you went through a whole experiment, you've used the scientific method, so we're going to go through it really quickly just to remind you. Okay, so it's a 5-step process used for empirical investigation of a hypothesis under conditions designed to control biases and subjective judgments. Those are two terms, control bias and subjective judgments, that we're really going to go into a deeper level later on, but let's start with the scientific method. Okay, so the 5 steps of the scientific method are developing a hypothesis, performing a controlled test, gathering objective data, analyzing the results, and publishing, criticizing, and replicating the results. So what are all these steps entail? Okay, so developing a hypothesis, a statement of predicting the outcome of scientific study. Like, I think that all humans like chocolate. Okay, so that's my hypothesis. I predict that all humans like chocolate. All right, so one of the terms that fall under this hypothesis is the operational definition. What is going to be my exact procedures used in establishing experimental conditions and measurements of a result? So my hypothesis is all humans like chocolate. My operational definitions is how am I going to prove that? Okay, so for instance, to test my philosophy, I'm going to put a piece of chocolate and a piece of fruit candy that is not chocolate based, like a Starburst, and have people choose. Okay, so what I'm going to do is my operational definition is I'm going to have a piece of chocolate and a piece of fruit candy, and I will have people choose which one they are going to have, and then I'm going to record those results. That is my operational definition, the exact procedures of how I'm going to carry out testing my hypothesis. Okay, so now that I've created the outlines for my hypothesis and how I'm going to actually test it, now I need to actually figure out how I'm going to do it. One of the major concerns is when we do have an experiment is the independent variable. The independent variable is the variable manipulated by the experimenter. So in my experiment that all humans like chocolate, my independent variable is going to be my choices, the chocolate and the Starburst. Okay, so the independent variable is going to be my 2 choices. There's not 5 choices, there's not 6 choices in different types of chocolate. There's only 2, chocolate and a fruit-based candy. Now the random presentation, when we are performing it also matters, using chance alone to determine the order in which the stimulus is presented. Okay, I'm going to present both options at the same time so they have a random presentation. It's not like I'm presenting the chocolate first, and once they take the chocolate, I then show them the fruit to see if they change their mind. I'm giving them the opportunity, I'm giving my test subject the opportunity to determine or to choose without any bias. Okay, so once I now have my hypothesis, I now know how I'm going to test it with my independent variable of the fruit. Okay, I know how I'm going to present the information to my test subjects. Now, once I'm actually doing my experiment, I have to gather my objective data. The data is the information gathered by the researcher used to test the hypothesis. So say I do this test with 300 people. I will have a data, I will have the information whether they picked chocolate or whether they picked fruit for all 300 people. Okay? The dependent variable, we just had the independent variable, now the dependent variable is the measured outcome of the study, the responses of participants in the study. Okay, so the independent variable is that I had both a chocolate and a fruit option. Okay, I presented it to them. That's the independent. The dependent variable is the measure of the outcome of the study. Okay, I presented two options. Everybody chose one of those two options. That becomes the dependent variable. Okay, so I've marked down which one everyone chose. All right, so after I've done this 300 times, I'm now analyzing the results. Nothing has been analyzed of the data. I've just been collecting the results, recording them. Once I have all 300 results, I'm going to statistically analyze all of the results, and I'm going to see if my hypothesis was proven or disproved. So, was chocolate the more popular option, or was the fruit one a more popular option? Is it accepted or rejected? Okay, so once I start analyzing my results, I'm going to see if my hypothesis was right or wrong. If my hypothesis was right, I have the statistical evidence to say it's right, this is what happened, this is the percentage, 75% of the time, if that's accurate. Most people have preferred the chocolate. If it was wrong, I'm going to have to analyze and say, okay, why do I think it was wrong? Okay, looking at all data. Okay, so once we analyze our results, we then publish them or put them out there in the world so other people can use this information. Researchers must find out whether their work can withstand the scrutiny of the scientific community. If you do an experiment correctly and you follow step by step and you do this with an unbiased opinion or investment into the results of it, then you should be able to publish it. There should be some positive and negative criticism on your findings, but the most important thing is that your results should be replicated. So if I came out doing this whole experiment, I created my hypothesis about chocolate candy, I made my controls for this experiment, and I saw it after I went through and gathered all my data and analyzed that 75% of all people chose the chocolate over the fruit candy. Anybody can set up the same experiment and find out pretty much the same results. That's the importance of replicating an experiment. It's not just true in one case, it's true in all cases. If someone does the same exact experiment you did, they should be able to replicate the same results. And that's the importance of research. That's how we know it's valid. Okay, so those are the 5 steps of the scientific method. Okay, so we use the scientific method to do all types of psychological research. All right, in experiments, we typically think of the 5 steps of the scientific method. In experiment, the researcher controls all the conditions and directly manipulates all the conditions. When you think of an experiment, you think of a white room with a doctor in a white coat testing all different types of things. Experiments are completely controlled. Everything a person sees, touches, smells, hears is completely controlled by the researcher. Non-experimental methods are a lot different, okay? There's a lot more factors that interfere with non-experimental methods, okay? Some of them are correlational studies, surveys, naturalistic observations, longitudinal studies, cross-sectional studies, okay? All of these things are done in our natural environments, okay? I can pass out a survey in class tomorrow. That would be a non-experimental method, but it does create research, okay? It is not an experiment because I'm not controlling all situations, okay? That's the major difference. Think of experiments in a white room. I control everything. Non-experimental is done in the real world. Well, I do not have control over all aspects. Okay? And cohort sequential studies, we'll talk about that one a little more in detail later. Okay, so let's get a little further into experiments. Now, experiments are done where the experimenter controls everything. It's a manipulation of an independent variable under careful controlled situations to see whether any changes occur in the dependent variable. Okay, so just to clarify, an experimenter creates and formats an independent variable. Okay? So, for instance, if I have a piece of chocolate and fruit, that is my independent variable. The dependent variable, okay, what's depending on that independent variable is the action of the person, okay, what they choose. I go into a little more detail below just to help clarify. The independent variable is a condition or an event that the experimenter varies in order to see the impact of others. Okay, so it's called independent because it's free to be varied by the experimenter. Experimenter controls the independent. The dependent variable is the one that's affected by the manipulation of the independent variable. Okay, dependent relies on the independent. Independent's controlled by the experimenter. Dependent variable is focused on the results or the actions of the person involved in the experiment. Okay? It depends on the independent variable. Think of it like that. I know those two terms get a little confusing. Okay? So why is experimental controls important? We kind of talked about it. There's many different forms of controls. The two biggest ones are control groups. Okay? What that means is the experimenter controls what subjects, test subjects, get certain aspects, all right? Who receives a special treatment in the experimental group and who doesn't. When we do an experiment, we have to have a control group and an experimental group. Control group is one that does not receive special treatment. So let's think, for instance, of a test of a drug company running a test to see if a new diet pill works. We have a control group and experimental group. The control group pulls from the same population the experimental group comes from. Okay? Same type of people, all 20 to 50 years old, men and women, a whole cross-section of ethnicities to give a good, solid representation of the United States population. The control group is a certain amount of a cohesive cross-section of that entire group that does not receive the pill, the diet pill. They receive a placebo, a sugar pill in replacement. It's important that they receive the placebo to think that they are, in fact, receiving the drug. Now, the experimental group, in that same context, are the ones who receive the special treatment or receive the actual drug pill. Okay? Now, the importance of the control group and experimental group is we've all seen the ads that, people who have taken this diet pill lose 15 to 30 more pounds than those who don't. Well, the control group is what would happen if you didn't take the pill, and the experimental group is obviously taking the pill. That way we have a basic understanding of how much influence and how much effect does that diet pill actually have. Control group, nothing changes, everything's the same. They are the foundation, okay? They are the core. The experimental group is the one we're measuring the change, okay? Control, nothing changes, no drugs, no special treatment. Experimental is given the drug, given the special treatment to see if there's a change, there's a genuine change. If we have nothing to compare the difference to, then we have no true context of how much of a change has actually occurred. Okay, now variables, we're going to talk about variables as we go through. What an operational definition is a definition that describes the actions or operations that will be made to measure or control a variation. What we need to do is when we set up an experiment, my chocolate and Starburst experiment, we need to specifically outline the behaviors of the researcher, how to set up the perfect experiment to make it consistent. That's exactly what the operational definition. For instance, in my experiment, I'm going to have a box that covers the chocolate and the Starburst, one box. I'm going to sit down my test subject in front of them, have the chocolate 3 inches away from them, in the same location, 3 inches away, 3 inches apart, so the subject has equal opportunity to reach one. There's no bias in my placement, okay? And I will lift the box for 2 minutes, and whichever they reach and pick up is the decision they've made. If they don't make a decision after 2 minutes, I cover it up. The time is expired, okay? That's my operational definition. It describes every action and procedure of how this experiment is going to work. Okay? Operational definition. Now, the importance of experimental controls, okay, we kind of just talked about it, but I just really want to reiterate, is that control groups are not getting treatment, experimental groups are getting the treatment. Okay? All right, just talked about that. All right, so let's talk about positive and negative correlations. All right, a positive correlation, you probably should have heard about this in math class. This week you're going to actually hear a lot of things that you've heard and you should have done in many of your other classes. You'll see what I'm talking about as we get going. Now, the positive correlation indicates that 2 variables covary in the same direction. Okay, that means they are very similar. For example, there's a positive correlation between a high school grade point average and a college GPA. Okay? If you do well in high school, you're more likely to do well in college. There's a positive correlation. Okay? There is a relationship between high school GPA and college GPA. If you do well in high school, you'll do well in college. If you do poorly in high school, you'll do poorly in college. Okay? There is a relationship. They are positively correlated. There is a negative correlation, indicates that 2 variables covary in the opposite direction. Okay? So, for instance, most college courses, there's a negative correlation between students' number of absences tend to get low exam scores. So the more student absences, the lower the score, okay? So one's going up, more student absences, and one's going down, okay? So both of these are going in 2 separate directions. If we plotted all this information on a scatter plot, what would be is that the points are going in 2 separate directions. In a positive correlation, all of these dots are going in the same way. I have a picture to show you to help clarify that. Okay? Positive correlation, 2 variables go in the same direction. Negative correlation, they're going into opposite directions. Okay? Here's a perfect example of a positive correlation. You can see that SAT score, the higher your SAT score, okay, 1600, the higher your GPA is going to be. Okay, positively correlated. All the points are going in the same direction. Here is no correlation. If there doesn't seem like there's any order to it, okay? If there's height in inches, how tall you are, how does it affect your GPA? Well, is there any? Absolutely not, okay? It doesn't matter if you're 70 inches tall, you may have a 4.0 or you may have a 2.0. No one really knows. There's no correlation. Now, this is what a negative correlation looks like. The number of drinks per day to how high your GPA is. All right? If you drink more, your GPA is going to be very low. The less you drink, the higher your GPA. That is a negative correlation. Okay? You can see that it's sloping down. The more of something else, the lower something else gets. Okay? That's a negative correlation, and a positive correlation we saw on the rise. Negative goes down. Okay? All right. So let's talk about another tool, survey research. A survey, researchers use questionnaires or interviews to gather information about specific aspects of participants. Keep in mind, this is not an experiment. This is what we do informally. Okay, they are used a lot, but they are not as highly structured as an experiment would be. Okay, naturalistic observation. A researcher engages in careful observation of behavior without intervening directly with the subjects. A perfect example is Jane Goodall. Jane Goodall, you all should probably be pretty familiar with her. She spent 18 years living in the jungles of Africa, watching and living amongst the gorillas. And what she did is she just sat and watched and wrote in her log of what the gorillas were doing every single day. She just sat and just observed. Naturalistic observation. You don't interfere. You don't ask questions. You just sit there and draw conclusions from what you're seeing. So Jane Goodall and the gorillas in Africa are a perfect example of naturalistic observation. Okay, this just goes into a little bit more detail for you. It's classified under non-experimental approaches, just like surveys. Researcher very carefully observes, records, and once they collect enough information, then they start assuming. It's done over a very long period of time, not short periods of time. You can't collect enough data to really get an understanding. The most important thing to understand about naturalistic observation is there's no intervening with the subjects in any way. There's no interaction, no asking questions or anything like that. We typically do it obviously with animals. You can't have a conversation with an animal. We do it with humans as well, but not typically as common. We do like to get in there and ask questions. We're inquisitive beings, but we do this a lot with animals. Okay. The strengths of it, why it's important, is it allows researchers to observe behavior in which the behavior normally occurs. Now, if you get in there and ask questions and get involved, then people are going to start acting uncomfortable and not be acting the way they usually do. Okay? So the strength of naturalistic is people are actually doing what they would be doing whether you were there or not. You actually see how animals behave in their own way, not just studying them in a laboratory and assuming that's normal, because it's not. Limitations, it's only descriptive. We can only describe what we're seeing. We don't understand everything. We're not really explaining why things happen. We're making conclusions of this happens because of this, but there's no concrete fact beyond this is what they did, this is their behavior. Okay, cause and effects relationships cannot be drawn completely. We can try to make conclusions, but we can't do this unless we have a completely controlled condition. Okay, also this is very time consuming. It takes a lot of time to be able to observe and behavior over long periods of time. It's also difficult to observe behavior without disrupting. Okay, and it's also difficulty coding results to find the appropriate statistical analysis. Okay, very important. So to sum it up, we don't get a full understanding in the limitations. It takes a great amount of time, and it's difficulty observing without disrupting. Okay. Case study is an in-depth investigation of an individual subject. Now, case studies can be a little difficult because of how we use them. A case study refers to a collection or presentation of detailed information. So, for instance, if someone wanted to do a case study on me, on my life, or on your life, what they would do is they would sit, they would talk to you, ask questions, follow you for a very long amount of time. The participants or small group include accounts of subjects themselves. They would ask interviews. They would participate in question and answering. They'd be giving forthwith information. They would explain it. It's an intense look at an individual or small amount of people, experiences, thoughts, anything specifically, and it would only affect those small amount of people being interviewed. Typically, we do these with individual cases of people. They're most effectively done with people, individuals. Like, for instance, if we wanted to see what life was like for the President of the United States, then what you would do is we would have someone going in and really spending a lot of time with President Obama, looking at how his life, the stress. That person would have to be given full access to his public and private life. Okay, and the biggest thing is that all that information is only for that one person in that specific context. So case studies are a little bit tricky. It's a very in-depth, detailed information about a particular participant. Okay, why we use case studies is because we're looking for a universal truth, that, you know, for instance, if we're looking at my life at a very intense way, what is something that we can assume or kind of apply elsewhere, and how can the information collected about my life or President Obama's life or whoever the case study is about, is how can we get more information and explore and describe it in a more cause-effect relationship, okay? We're trying to get a deeper understanding about that individual person. Okay, so as we're doing all these different types of experiments, we're having to deal with bias. Okay, all experiments have some sort of bias. Every single one. We have to explain what's the bias, how did it affect it, and we're obviously trying to keep them as minimal as possible. But everything you do, you have a bias towards. So what are some biases that we deal with as experimenters? Because this week and for the rest of the year, we are psychologists. We are going to be analyzing experiments, thinking about them, creating our own, and going through it. So what are some biases that we deal with? Source bias. We have all personal bias. Now, if I asked you to complete a case study on someone who lives in Africa, or somewhere who doesn't have plumbing, who doesn't wear the same types of clothes, automatically you have a personal bias. You don't understand where they're coming from. All right? You don't understand how your own experiences affect theirs. That's a personal bias. We also have an expectancy bias. Reflecting back onto my experiment that we started with of the chocolate and the fruit, which one would be more popular? My hypothesis was chocolate. Well, what happens if I do that experiment 300 times and the fruit one is more popular? I could possibly be like, well, why, interfering with my own results by thinking and acting on my hypothesis of, well, it should be chocolate. Why aren't these people choosing chocolate? All right. Bias could affect the way an experiment is designed to study, collects data, or interprets results. We have to make sure that we are giving all opportunity for the subject to act with their own thoughts and their own ideas. As an experimenter, we can manipulate our participant in any way. We want to make sure that they have complete control of their own choices so we can get true results and without any bias. Okay, the most effective way to do a experiment is a double-blind experiment, and why that's important is because it attempts to control all biases. Now, an example of a double-blind study is if we're doing a drug test, okay, and we have a control group who is not receiving the drug. We have an experimental group who is receiving the drug, and we obviously have a doctor or physician who are handing out those drugs or those placebos to those two groups. Now, if the physician who's obviously conducting this research knows who's getting which drug, they may by accidentally hint or put more emphasis on the experimental group than on the control group. So what we do in a double-blind study is that the actual physician who's handing out all these pills to both the control and the experimental group has no idea who's receiving the actual pills and who's not. That way there is no bias on behalf of anyone interacting with our control and experimental group, because no one knows who's receiving, who is in the control group or in the experimental group, except a third party who is completely removed from interacting with either of the groups. Okay? Researchers also must attempt to control confounding variables. Things happen, results that may surprise the experimenter can pop up at any time. We try to limit those choices. Like, for instance, I could have had multiple different types of chocolate. I could have had multiple types of different fruit candy. In order to make it easier and limit as many confounding variables as possible, I only made 2 choices. 1 piece of chocolate, 1 piece of Starburst. That's it. Trying to eliminate the complicating details. So we do these fantastic experiments. We have a control group, we have an experimental group, we have all of this wonderful research. How do we analyze the research? How do we get the most information out of all this data we've collected? And how we do it is we use descriptive statistics. Okay, they are used to organize and summarize data. Some of the most common ones are central tendency, measures of variability, and correlation. We've kind of talked about correlation earlier. Now, central tendency, you should have been doing this since 4th grade. Mean, median, mode, you should be very familiar with these terms. These are very helpful for experimenters. And we'll go into further detail how we actually use them. Measures of variability, how much the scores of set data vary from each form from the mean. We talk about this. If you've ever seen your SAT scores or ACT scores or even FCAT scores, you're going to see this information, measures of variability, how you compare to others. And that's what experimenters and everybody else wants to know. How much of a difference does each person make, and how do all of those scores form around the mean and the median, okay? And correlation, 2 variables related to each other. Are they positive or negative? All of this information is incredibly important to understanding all this fantastic data that we've just created. So, inferential statistics, some of you are taking AP stats. You'll be really getting into this. We're kind of just going to glaze over it a little bit. Inferential statistics are used to interpret data and draw conclusions. Okay, we've conducted our experiment. We have all this raw data. Now we need to see how it actually applies. Okay, now our data tells us information. We've created this hypothesis, we've gone through the scientific method, but now we have to look at the data as brand new without any bias at it and let the data tell us what actually occurred. Okay, so we work with probability. Inferential statistics is used to evaluate the possibility that their results may be due to fluctuations of chance. We cannot eliminate all chance, okay? Think back to our chocolate and fruit. Some days, most people, like for instance for me, I would 95% of the time choose a chocolate piece of candy. But, maybe the day that I'm sitting down and taking this experiment, that I just had a piece of candy, a piece of chocolate candy 10 minutes before I walked in, maybe I really want that fruit chance. Maybe I really want that fruit. Not my normal choice. There's a fluctuation of chance. Inferential statistics evaluates how much chance is in our experiments. Now, if there's a huge percentage of chance and how they're unreliable, then that makes our experiments less worthy and does not validate our experiment. We'd have to redo it and try to eliminate some of that chance. That's how important inferential statistics are. Okay? So we do all these experiments. We just can't do whatever we want. We're going to be talking about some very, very famous experiments that I'll be showing you clips of. You'll see the original research. We're going to go through it. That you cannot redo these experiments today because they violate so many ethical codes here in psychology. So we have these famous experiments and we have all this research, but we can't replicate them. Well, the reason why we can't do that is because of the ethics. So what are the ethics? what can we do and what can't we do in psychology research? Okay? We cannot use deception. We all in all cannot lie to our subjects and say one thing and test them for something else. We can't do it. Okay? We need to debrief them after we've done this entire experiment. We need to tell them exactly what we found, why we did it, and what do the results tell us. Okay? Animal research is allowed in psychology. We do use it, but that doesn't give us free use of animals or abuse. Okay, there's very certain limitations that we can actually use animals for. Like, for instance, we can't cause them any physical harm. We can't, truly make their lives miserable in the name of research. Okay, we have to be humane with our research. Okay, so with all of those ethical codes, there's some questions science cannot answer. Even though we do all these experiments, we held ourselves to a high moral code, ethical code, there's some questions we cannot answer. Okay? The scientific method is not appropriate for all circumstances. Okay? You cannot test or do an experiment that cannot be put in an objective empirical test. For instance, okay, ethics. There's no experiment to see how ethically people handle certain situations. In order to really challenge someone's ethics, we'd have to put them in a situation where, it could be hazardous, it could cause mental harm, anything like that to the person who was to our test subject. It goes against all the ethical codes of research to test someone's ethics. Morality, we can't examine how people deal with death in different ways without voiding our ethic code of researchers. Religious beliefs, you cannot test them empirically and objectively as a researcher. They're too complicated. Okay? Preferences, how people determine all of these things. You can't really test it without going against, like I said, all of our ethics and all of that stuff. Okay? Very difficult to test, so you won't see many true scientific research on any of these topics. Okay? So a little bit more in depth about the ethical codes. Stress and harm you cannot injure or hurt your test subjects. Okay? Even though previously, before the APA has become incredibly hands-on on this, there have been experiments that did cause stress and harm. Those cannot be replicated. Now, here in 2012, and especially over the last 10 or 15 years, this is a very big issue that you can lose your license and even jail time. Deception, deception's a little bit tricky. It's an important part of psychological research. We can't let everybody know exactly what we're doing. However, we can't just all out lie to them. And the best way we do this is a double-blind studies. That way we kind of control all expectations. If we tell someone everything of exactly what we're testing, then we may not get a true sample. So deception, it's a little bit tricky, and we're going to go into it a little bit more in class. Informed consent, all individuals must read and sign a release that they've been informed of the general nature of the study. Okay? Everybody must be able to voluntarily withdraw from the study at any time. Okay? A participant cannot be forced to be involved. They have to be given the option to leave. They have to be being told that they have signed up for something and be a part of it. Okay? Debriefing is also essential. Our studies are, all of our patients, our research, our patients need to be told of what is actually detailed information about the study, why it's important, what their contribution has contributed to. If people have been through a stressful experience or maybe, not coping as well, then counseling must be offered. Okay, you can't just do an experiment and send them off into the world and say good luck. There needs to be some way to help these people recover if it's been something like that, as well as make sure they know exactly what all this information is going towards. Okay, privacy and confidentiality. The only people who are supposed to know the true names are the actual researchers. All published information, there's absolutely not okay to publish anybody's name. I can't say that Joe Bob came into my experiment and this is what his results, and they're so important because blah 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 blah. No specific names can be identified in any way to let anyone know anyone's identity. Okay, coercion. No person can be forced to participate. Okay, so we have all this information, we have all these ethical codes, we have all this beginning of all this information. How do we start making sense of the data? So we've started analyzing some of the data. We use inferential statistics, we started using mean, median, mode, but how do we make it all make sense? How do we get the most out of all this information? Okay, researchers use statistics. We use descriptive statistics and inferential statistics to measure the amounts, okay, to results in change. This is the biggest, most important aspect. Okay, we've done the research, yes, we have the data. Now we need to understand what it says. Okay, so descriptive statistics include mean, median, mode, range, standard deviation, and normal distribution. Descriptive just allows us to take the information that's there and break it down into more meaningful information. Okay, we're not applying it, we're not seeing the relationship, we're not assuming anything, we're just trying to get a better idea of what the information is telling us in more specific details. Okay, I'm going to fly through this stuff, you guys should know this. Mean, most common sense of central tendency, it's the average. Median is the number presented in the middle when all numbers of the data set are arranged. Mode is the value that occurs most frequently in a set of data. Okay, mean, median, mode. You should have done this since like 6th grade. So flying through it. Okay, for the data I have up here 1, 2, 3, 4, 5, and 6. The mean is you add all those numbers, divide it by 9. Okay. And the total comes to 41 divided by 9. Your mean or your average is 4.56. Taking all those numbers, the median number is 5. The mode is 5 because you see that number twice up there. There you go. Okay, so other descriptives, statistics, central tendency, variability, correlation. Okay, so let's talk about the next one. So correlations, a relationship between two variables, one variable reflected in change. We kind of talked about positive, negative correlation with those graphs earlier on. The correlation coefficient is a number between -1 and +1 expressing the degree of relationship between the two variables. Okay, so if we have a very strong positive correlation, the correlation will be described as +1. If we have a very, very, very negative correlation, it's going to be -1. You typically don't see -1, +1. You may see the correlation of, positive 0.75. That's a typical one if it has a positive correlation. But those are the extremes. Everything falls between those two sets. All right, so making inferences with inferential. So we just talked about all the descriptive stuff that just takes all the information that's already there and puts it in more meaningful, smaller bits of information, mean, median, mode. Okay, so now we're with inferential statistics. We're actually taking the information that we've collected and we're now trying to make connections or develop some sort of relationship between the results. All right, they are used to assess whether the results of a study are reliable or whether they're simply result of chance. How we do it is we do sampling by controlling who's in our population of participants. We can control how much chance there is in a representative sample. A random sample means is that we just go out and pull a bunch of people in and we test them. We don't care who they are, how many men, how many women. We just go out, grab people, bring them in, and test them. Random sample. A representative sample is, say for instance, we're doing this diet pill for the United States. We pick specific people that represent the population of the United States. Okay, so say the population of the United States is 54% men and 46% women, then in our representative sample we're going to have 54% men and 46% women. If the population is 36% white people, then in our representative sample we're going to have 36% of our sample is going to be white. If 30% of our United States population is Hispanic, then in our sample we're going to have 30% of our participants are Hispanic. Okay, so representative sample is looking at the population that we're trying to use this information for is actually going to be represented in our sample. Okay, we're also looking at statistical significance. If we see data that is pointing in one way, we need to figure out why is that data going in that way. Why is the data dictating that? Okay, one of the major ways we do this is by standard deviation. We use standard deviation in all of your SATs, FCAT, ACTs. We're also going to be doing them in class. I use them all the time. Standard deviation is the mean of the mean. Essentially what it means is how far are people from the mean or the average. And we use standard deviation because it makes it easier to visually see how people fit and how people are grouped. To understand this concept, we have to learn about normal distribution. We're going to talk about that next. Normal distribution is of data that means the most of the examples in a set are close to the average, when relatively few examples tend to be an extreme or the other. Okay, so visually let me show you what this means. Okay, so what we have is a bell curve right here. Okay, this is a normally distributed graph. Okay, we see that it's very low at the bottom. Now think of this scale as 0 to 100. Okay, think of it as like a test scores. We have very few people who really fail a test. We have very few people who score really, really high on a test. Most of the people who take a test are going to be right in the middle. Okay, some do pretty well, some do kind of bad. Most people are in the middle. We don't have a lot of extremes. Okay, so for instance, the X value, the horizontal one is the value in question, calories, dollars, points on a test. The Y-axis is the number of data points for each value. Okay. Now this whole shape is known as a bell curve. Now let's get a little bit more detail into how standard deviation deals with this bell curve. Okay, so the standard deviation is the statistic that tells you how close you are to the median and how clustered you are from the mean. So when the examples are pretty tightly bunched together, the bell-shaped curve is steep and the standard deviation is small. Okay, we're going to talk a lot more about this in class. We'll be working through this all year. So if you don't have a great understanding, we'll be talking about this in class this week, and I'll give you some insight and how to make this as simple as possible, so don't stress out about it. All right, the further the examples are, the farther they are. Now look at my sheet, my bell curve at the bottom right here. You'll see the dark blue is located at the very lowest and the very highest. Very small percentage of people fall into this section. Okay, you see my red section, which is in the center of the bell curve. That black line in the center of the bell curve, that's my mean. That's the exact average of this whole bell curve. You will see that that's the largest section of height of the bell curve. Most people fall just above the mean or just below the mean. I'm going to talk about the percentages coming right up right now. Okay, so that red section is where most people fall. Okay, so one standard deviation away from the mean is in this red section. Okay, roughly everyone in this one standard deviation is around 68%. 34% of people fall one standard deviation from the mean. 34% of all people are one standard deviation above the mean. One standard deviation is that line where it changes from red to green, okay, above or below the mean. Now, if we start looking at the red and the green, we start having 95% of our data is located right there between the green and all the red sections. Now, if we're talking about the green section, you are 2 standard deviations away from the mean, or above or below. Okay? All right. Now, the 3 standard deviations, the red, the green, and the blue areas account for 99% of all people. Okay? We're going to talk about this a lot more. I'm just giving you a little insight